Hello, and thanks for joining me for the last of 3 videos for section 8.4 of the Calculus BC book about improper integrals. What I'm going to do in this particular one is get you set up ready to do the exploration on page 463 of the book. And this is very similar. Here we're taking the integral from 1 to infinity of dx over x to the p, where the exploration is dealing with the integral from 0 to 1. So you'll be able to use a lot of the same techniques to do this. So let's go ahead and get right into the example. Start off with the integral from 1 to infinity of dx over x to the p, and we're going to look at it for p greater than 0. So first thing we could do is we could change that x to the p to a negative exponent, so x to the negative p, and that way we'll be able to use our integral rules. Except for this is an improper integral because the upper limit of integration is infinity, so we need to be able to rewrite that as a limit. So throw in the limit notation here. We have the limit as b is approaching infinity of 1 to b of x to the negative p dx. Now we can just use a simple antiderivative rule. Add 1 to the exponent, so it's negative p plus 1, and then multiply by 1 over negative p plus 1. And limits of integration are from 1 to p. So now we just need to plug those in. So we'll plug in the limits of integration. You can see that's up here. We end up with the limit as b approaches infinity, that still carries through, of b to the negative p plus 1 over negative p plus 1 minus 1 to the negative p plus 1 over negative p plus 1. And then we can start evaluating that and see what's going on. So let's take a look at that. See what happens. Well, notice if p is less than 1, then negative p plus 1 gets bigger and bigger as b approaches infinity. Okay, so again, p is less than 1. So if p is less than 1, that's still a positive number. So as b gets larger and larger, we're raising to a positive number, so it'll get larger and larger. And therefore, that part of it's going to diverge. So you won't actually get an answer out of this. Meanwhile, we have the last case. If p is greater than 1, so I think if p is greater than 1, then we're taking b and raising it to a negative number. So we'll have a negative exponent, and that piece will go to 0, and therefore the integral will converge. All right, so hopefully that will help you get through that exploration. That exploration helps you set up some of the rules that you need to know for doing improper integrals, and actually helps set us up later to deal with how to use, for the later on. Wow, I went this far into this video, but in chapter 9, we end up going a lot more into power series and Taylor theorems, and we're going to have all sorts of things about series. So all that convergence idea is going to carry through to there. Sorry for that strange little delay in here. And thank you, and look for my next video for section 9.1.